In this video, I teach you a stage of combustion in SI engine. So we understand this video in these details by using this different graph. So in an internal combustion engine, if inlet and exhaust valve are closed and piston move from bottom dead center to top dead centers, compression will take place. And during the stage of combustion in SI engines, we draw the pressure versus crank angle diagram, and crank angle is known in the theta. So it is starting from the BDC. So it is here written 0 degree. It read to TDC. At that time the crank is rotated 180 degree. So here written as 180. And again it moved from TDC to BDC. It is a 180 degree motion. So it is 360 and the piston is reached to bottom dead centers. So when both the valves are closed and piston is moved from bottom dead center to top dead center, at that time what happen inside the cylinder? The fresh charge means it is a SI engine, means there is a mixture is available inside the cylinder, that is a air and petrol mixture. It is known as the charge. So this charge pressure is start to increase. So we draw this line and it is known as the compression. And when this piston is reached top dead center, at that time maximum pressure is achieved. Then after compression, the similarly piston is start to move from top dead center to the bottom dead centers, and at that time the expansion will be takes place. During the expansion, the pressure is reduced. So during the expansion, pressure is reduced with increasing in the crank angle. So if combustion does not takes place during this process, so at that time what we assume, the combustion is not takes place inside the engine. So the pressure P versus crank angle theta diagram obtained is known as the motoring curve as shown in figure. Means this curve is known as the motoring curve that you seen in this image. Now next we moving ahead. During that the combustion is takes place at TDC and before TDC and after TDC. Then after we cover onto the different 3 stages of combustion in SI engine, so you can understand it easily. Before moving ahead, I request to like the video, subscribe the channels, and also visit the playlist for watching the various video related to mechanical engineering. So figure shows the theoretical pressure crank angle, means P theta diagram, where the spark occur at the TDC. So at that time, when the compression is complete at the TDC, so at the TDC point spark is occur. So due to the spark, the pressure is suddenly rise due to the combustion, and the expansion means after this combustion the expansion is start, and this expansion of the which product is start, that is a combustion product takes place. Means after the combustion, it is known as the combustion product or the gases. So these gases are start to expand and the piston is moved from this TDC to BDC. So we take this type of the graph when the spark is occur at the TDC. Now this is the actual stages diagram. It is the crank angle and it is starting from this various angle. Here it is the TDC point 0, and then after it is start to BDC. Means this region is known as the before TDC region and this region is known as the after TDC region. So actual P theta diagram with the combustion is shown in this figure. As discussed earlier, process of combustion is very complicated, but as per figure it is divided into the 3 stages. Which 3 stages? First stage, it is A to B and it is known as the ignition leg, that we understand in detail later on. So in this figure here you see that yellow line, that is A to B region. It is known as the ignition leg, and A point is the sparking point. So at the point A the spark is occur inside the engine, and A to B is the ignition leg period. Stage 2, it is B to C and flame propagation. So this red region, that is a B to C, this region is known as the flame propagation. And then after stage 3, that is a point onward C, means this complete region is known as the after burning. Means after burning is takes place only C to D process. Now to achieve the maximum advantage of the high pressure, which is the high pressure at the point C, and this high pressure in this image is after TDC, means 0 line is here TDC. So after TDC, inside the cylinder maximum pressure is occur. So to achieve the maximum advantage of high pressure generated during the combustion, the peak pressure should be after and near to the TDC, means After means after this TDC and near to the TDC. It's not need to be far away. Then it is a disadvantage for us. So this peak pressure is required to near this TDC. Now if the peak pressure is before TDC, means this is the TDC line, so it is achieved in this region, then what happen? It produces the negative force on the piston, which may damage the piston and piston rods and the crankshaft. So before TDC peak pressure is achieved, then what happen? The piston is try to move in upper direction, but this combustion product is tried to push the piston in downward directions. So this create the negative effect. Now if peak pressure is after and far away from TDC, means peak pressure, this point number C is far away from TDC, means it is on this region here, then what happen? That cannot be, energy is not completely utilized, so power production is reduced. So considering the above fact, the spark timing is at the point A, and shall be selected that maximum pressure will be after and near the TDC. Now we understand the stage number 1, A to B, it is the ignition leg. What is the ignition leg? Ignition leg means, suppose I give the just simple example is that, suppose we go to start the candle, means propagate the candle at our home by using the matchsticks. Then what happen? We start the matchstick, okay, and go to the propagate the candle. So at that time we require certain time. So this time is known as the ignition leg. So similar thing is happen in IC engine. So that is a spark is takes place at the point B, but at the point A combustion does not start. It takes some time. So it is known as the ignition leg. So what is the ignition leg? Ignition leg is the durations between the spark point A and the starting of the combustion. It is the point B. So combustion is directly not start, it's required a certain time. So this time is known as the ignition leg time. So at the point B, first rise of the pressure is detected and actual curve is start to different from motoring curve. Means earlier we studied the motoring curve. So up to this point B, motoring curve is same. So actual diagram is different from the point number B. Okay. So the time intervals between the spark, means at the point A, and the first pressure rise, means point B, is known as the ignition leg, and generally it is expressed in a term of crank angle theta. Ignition leg is also known as the preparation phase, during which spark chemical process takes place and the flame is generated. So it is a ignition leg is also known as preparation phase, during which spark is occurs. After the spark, some chemical process takes place, then after flame is generated during this ignition leg period. That's why it is known as the preparation phase for the combustion. In SI engine, combustion ignition leg is very important, and it will be small as possible for getting the more power. Means ignition leg are require smaller, and it is expressed in terms of crank angles. So in a short crank motions, the combustion is start, then it is a good, means ignition leg is reduced and the more power is produced. Next is the state number 2, and state number 2 is B2C, and it is known as the flame propagation. Means during the B2C, the complete combustion is the takes place and the flame is inside the cylinders. It is known as the B2C. Means the flame is not completely generated at point B. At the point B, combustion is start, but for complete combustion it required a certain times or a certain angle of rotation of the crank, and this peak pressure is achieved at the after the TDC point. It is known as the flame propagation. So the time durations between the point B, means combustion start, and the point C, that is the peak pressure, is known as the flame propagation. So in this red region you see that, so B to C point, this is known as the flame propagation. Means at that time the flame is generated inside the engine. The most of the heat is generated during this phase. So at that time the maximum combustion takes place. So maximum heat is by default generated in this region. So during the combustion, maximum heat is generated in this B2C region or during the flame propagation. Normally spark will occur at the point A. It is approximately 30 to 35 degree before TDC. So here you see that in this image you see the 20, but approximately it is 30 to 35 depending on the speed. So that peak pressure is at the point C. It is obtained 5 to 10 degree after TDC. So here you see that it is a 5 to 10 degree after this TDC point, at the crashing speed. As the speed vary, the spark timings will be vary for getting the peak pressures at the 5 to 10 degree after TDC. So it is depend on the speed where the point number C is achieved. Okay, and last stage is the stage number 3. It is the point number C onwards and after burning. Here written is C onwards, but it is on the C to D regions. So up to D point the complete combustion is takes place. So from this name, after burning, you can understand what they say. Means according to the theory, the spark combustion is completed at the point C. Okay, means complete combustion of the fuel is takes place up to point C. But in actual, when the combustion is take inside the engine after the point C, it is known as the after burning. Means at the point C, the combustion must be completed. But after point C it's happened, then it is known as the after burning. Theoretically, we can say that combustion will be completed at point C at the maximum pressure. But actually combustion will continue after the point C during the expansion stop, which is known as the after burning. So during expansion, the combustion is there, then it is known as the after burning. So and it is shown in these figures by the green line. It is a C to D. So it may be due to the two type of the fuels, either it is a rich mixers or either a lean mixers. So about 10% of heat may be liberated during this stage. So maximum heat is generated during B to C, but 10% is liberated during this C to D process. So thank you for watching this video. If you learn, then like the video, subscribe the channels, and also share with your friends and comment on the video.